Hello everyone, welcome on our YouTube channel Physics Mate Easy Quota. In this video lecture, we are going to understand about the concept of the sensitivity of moving coil galvanometer, conversion of galvanometer into ammeter as well as into voltmeter, and at last what is cyclotron and how it is working. First topic of today's video lecture is sensitivity of a galvanometer. A galvanometer is said to be sensitive if a small current flowing through a coil of galvanometer produces a large deflection in the galvanometer. In this lecture, we are going to understand about the types of the sensitivity of galvanometer. The first one is a current sensitivity and the second one is a voltage sensitivity. Current sensitivity of a galvanometer is defined as the deflection produced in a coil of a galvanometer per unit current flowing through it. It can be increased by increasing the magnetic field by using a strong permanent horseshoe shaped magnet. It also increased by increasing the number of the turns of the coil. It also increased by increasing the area of the coil, but it increase with the decrease the value of the restoring force constant. Voltage sensitivity is defined as the deflection produced by the coil of the galvanometer per unit voltage applied to it. It can be increased by increasing the number of turns, by increasing the magnetic field, and by increasing the area of the coil. But it increased by decreasing the restoring force constant and by decreasing the resistance of the coil. Galvanometer can be converted into ammeter. First of all, the question comes to our mind, what is ammeter? Ammeter is an instrument. This instrument is used to measure electric current in an electric circuit. There are some things which are required for the conversion of the galvanometer into ammeter. An ammeter is a modified form of the galvanometer. If a galvanometer is used to measure the amount of the electric current flowing through the circuit, then the two things may happen. First of all, large resistance of galvanometer in a series with the circuit will change the electric current in the circuit. Secondly, large amount of the current in the circuit may damage the coil of the galvanometer, or also it leads to the burning the coil of the galvanometer due to production of a large heat. So we conclude galvanometer cannot be used to measure the current in the circuit. Galvanometer can be converted into ammeter by connecting a low resistance parallel to galvanometer. Let this resistance is represented by S, and its another name is known as a shunt resistance. For a conversion, we connect a galvanometer parallel to a shunt resistance, which is also known as a small resistance, in parallel combination, and let a current I flow through this combination, and the current Ig is flowing through the galvanometer, and the remaining current I minus Ig flows through the shunt resistance. Since both these are connected in parallel combination, so the potential must be equal. So using that, we get a expression V is equal to IR. So potentials are equal, so we applied the expression Ig is equal to I minus Ig multiply with S, and after doing the respective calculations, we get the expression for the S, and this expression is a required value of the shunt resistance, which is used to convert a galvanometer into the ammeter. Galvanometer can also be converted into the voltmeter. So first of all, what is voltmeter? It is an instrument used to measure the potential difference across the two ends of the circuit element. And for the conversion, there are the few steps or the condition that must be taken into the consideration. We already studied that if we want to measure the potential difference, the measuring device is to be connected in parallel to the circuit. If we connect a simple galvanometer in parallel to the circuit, it will also draw some current, and hence potential difference of the circuit will change and the measurement is not accurate. So for the accurate measurement, it is very important that the current between the 2 points of the conductor should remain same after connecting the measuring device across the 2 points. It is only possible if the resistance of the device is very high, or we can say that infinite, so that it may not draw any current. To measure potential difference, a galvanometer has to be converted into the device whose resistance is very large. So a galvanometer can be converted into voltmeter by connecting a large resistance in series to the galvanometer. So for the conversion, we connect a galvanometer and the resistance in series, and a current is flowing through it, and the same current flow through both the devices, and we can calculate the potential difference between the two ends of the circuit. And after doing the respective calculations, we get the final expression for the resistance R, and this value is needed for the conversion of the galvanometer into the voltmeter. Cyclotron. It is a machine which is used to accelerate positively charged ions to high energies. It is also used to accelerate the particles like protons, deuterons and alpha particles. It was a beautiful design invented in 1934 to study nuclear structures. In cyclotron, the charged particle which have to be accelerated is under the influence of electric and magnetic field, in which electric and magnetic field are perpendicular to each other. They play their own roles on a charged particle. Like the magnetic field make the charged particle to move in a circular path, and the electric field accelerate the charged particle. Cyclotron was first designed to avoid the need for a long linear accelerator to obtain high energy particles. Later on, it was found that the principle of the cyclotron is the frequency of motion of the charged particle whenever it is moving, it independent of the radius of the circular path and energy. So how this design is made? The cyclotron consists of two hollow semicircular discs, and these discs are like metal containers in the shape of alphabet D. So they are called as the Ds, as there are the two semicircular hollow discs, so they are called as the D1 and D2. A source of the positive ion or a positively charged particle is located near the midpoint of the gap between the Ds. The Ds are insulated from each other and enclosed inside another vacuum chamber. The Ds are connected due to a very powerful high frequency AC oscillator. The electric field is provided in the gap between the Ds. Inside the Ds, it is noted that electric field is zero or potential is constant. The whole apparatus is taken in a magnetic field. Let us assume that there is a positively charged ion and it is ejector. As soon as it is ejected, it is accelerated towards the Ds. Suppose it get accelerated toward the first D, and suppose which have negative potential at that time. Since the magnetic field is normal to the plane of the D, the ion undergo a circular path. After one semicircular path in D1, the ion reaches the gap between Ds. At that time, the polarization of the Ds are reversed, so that the ion is now accelerated towards D2 with a greater velocity, as this is also shown in the given representation. This process continues, and hence the particle undergo a spiral path of increasing radius if we keep on increasing the velocity. Once it reaches near the edge, it is taken out with the help of a deflector plate and allowed to hit the target.